this problem, we have a circle of 99 sheep, and we have one wolf. So we'll say the wolf here is at position 0. And the rest of the circles are occupied by sheep. Now, at each time step, the wolf randomly chooses a direction, either clockwise or counterclockwise, moves in that direction, and if there is a sheep at that position, the wolf eats the sheep. So we'd like to find the probability that the sheep initially opposite to the wolf is eaten last. So this sheep here, let's call this index I, we'd like the probability that this sheep is eaten last. So there are two things to note. There are two ways this can happen. Either the sheep at I minus 1 gets eaten before the sheep at I plus 1, or vice versa. The sheep at I plus 1 gets eaten before I minus 1. So let's make some notations. Let's say AI is the event that ith sheep is eaten last. And then let's denote B sub ij, the event that ith sheep is eaten before jth sheep. So we're trying to find the probability of A sub I. We want to know how likely it is that the ith sheep is eaten last. And we're going to use the law of total probability to break this up into two cases. The first case is where the I minus first sheep is eaten before the I plus first sheep. And the second case is where the I plus first sheep is eaten before the ith sheep. Or rather, I plus first sheep is eaten before the I minus first sheep. Okay. So now let's focus on each of these terms individually. So we'd like to compute the probability that the I minus first sheep is eaten before the I plus first sheep. So let's draw our circle again. So let's say here we have our circle. Here's our ith sheep, I minus first, I plus first, and this is our n minus first, and the 0th, since we have n total entities here. Now notice that this problem can be framed, the wolf starts from position 0. Notice that this problem can be framed as a gambler's ruin problem, where x starts with the amount of sheep in this left part of the circle, and y starts with the amount of sheep in this right part of the circle. So how many sheep do we have in this left part of the circle? Well, we have n minus 1 minus I plus 1 plus 1 sheep that x starts with. So this is what x starts with. And then on the right side of the circle, how many sheep do we have? Well, from 1 to I minus 1. So that's I minus 1 sheep. This is what y starts with. So adding these two values up, we see that in total, we have n minus 2 entities. So in terms of the gambler's ruin problem, we have n minus $2. And what we would like is for x to win, because we'd like I minus 1 to be eaten before I plus 1. So in terms of the gambler's ruin problem, we'd like I minus 1 to be reached first. So we'd like the money of y to be depleted first. In other words, we'd like x to win. And since the probability that x wins any given trial in the whole gambler's ruin setting is 1/2, the probability of x winning is n minus 1 minus I plus 1 over n minus 2. And this simplifies to n minus I minus 1 over n minus 2. And I want to clarify the probability. We said the probability that x wins any particular trial in the whole Gambler's Ruin random walk is a half. And the reason is that the wolf randomly picks a direction, either clockwise or counterclockwise, with probability a half. So the probability that x wins any particular trial within the Gambler's Ruin random walk was a half. And so according to the Gambler's Ruin formula, the probability that x wins is given by this result here. So now let's continue. Let's look at this term here. The probability that the ith sheep gets eaten last, given that the I minus first sheep was eaten before the I plus first sheep. So again, let's redraw our circle. We have our n minus first sheep, the 0th, where the wolf is, the ith sheep, I minus first, and I plus first. And we're given that I minus first is eaten before I plus first. So that means that whatever random walk the wolf does, at some point the wolf has to reach this position I minus 1 before the wolf ever reaches the position I plus 1. So before the wolf ever eats the ith sheep or the I plus first sheep, the wolf has to first eat the sheep at position I minus 1. So for every random walk that the wolf does, we can cut the start of that random walk up until the wolf reaches this index I minus 1, and we can consider what happens to the random walk after that point. So once the wolf is at position I minus 1, we'd like to know now what is the probability that the ith sheep gets eaten last. And for the ith sheep to get eaten last once the wolf is at position I minus 1, the wolf needs to circle around and eat the I plus first positioned sheep before he eats the ith sheep. And so this probability really is the same as the probability that the I plus first sheep is eaten before the ith sheep. And just like before, we can reframe this question in terms of the Gambler's Ruin problem, and we can say, well, from this index I plus 1 all the way to this index here, the I minus second index, how many sheep do we have? Or in terms of the Gambler's Ruin problem, how many dollars do we have? Well, that's all the sheep except 2, the ith sheep and the I minus first sheep. So there are n minus 2 sheep there. And then the opponent in the Gambler's Ruin problem then starts with only one sheep, a single sheep. And the opponent only starts with a single sheep. So our x here starts with one sheep, and y starts with n minus 2 sheep. So in total, there are n minus 1 quote-unquote dollars, if we're thinking in terms of the Gambler's Ruin. And so again, because the wolf is equally likely to move left or right, in other words, x is equally likely to win any particular trial in the Gambler's Ruin random walk, the probability that x wins is 1 over n minus 1. Now, once we know, so now the next term we want to find out is this here, the probability that I plus 1th sheep is eaten before the I minus first sheep. So the probability that I plus 1th sheep is eaten before the I minus 1th sheep. Now we could do the same calculation as we did in the beginning when we were computing the probability that I minus first sheep was eaten before the I plus first sheep. But knowing this result here, the probability we want to compute now is just 1 minus that. So it's just 1 minus n minus I minus 1 over n minus 2. Why? Because there are only two cases. Either I plus 1 gets eaten before I minus 1, or I minus 1 gets eaten before I plus 1. And since we know the probability of I minus 1 getting eaten before I plus 1, the probability of I plus 1 getting eaten before I minus 1 is just 1 minus that result. And so what we get here is I minus 1 over n minus 2. And next we need to compute this term here. The probability that the ith sheep is eaten last, given that the I plus first sheep was eaten before the I minus first sheep. So the probability that the ith sheep was eaten last, given that I plus first sheep was eaten before the I minus first sheep. And again, we can reframe the question in terms of a gambler's ruin problem, but we notice that this question is exactly symmetric to the question of finding the probability that ith sheep is eaten last, given that I minus first was eaten before I plus first. And we already computed that result, and we got 1 over n minus 1. So this result, by symmetry, is also 1 over n minus 1. And so plugging in these values, we get the probability that the ith sheep is eaten last equals n minus I minus 1 over n minus 2 multiplied by 1 over n minus 1 plus I minus 1 over n minus 2 times again 1 over n minus 1. And simplifying the expression, we get 1 over n minus 1. Now what was n? N was 100. We had 100 entities, 99 sheep, 1 wolf. And so plugging that in, we get the result, which is 1 over 99. So the probability that the sheep that was initially opposite to the wolf survives last is 1 out of 99.